All living things, from bacteria to mammals, are made of cells, tiny biological units that perform vital life processes. Cells are more than structure. They're active agents that carry out the functions that sustain life and growth. The human body's trillions of cells operate as a system, much as tree roots form networks to draw nutrients from soil. In every organism, cells take on specific roles while staying in relationship with their surrounding environment. Earth itself is a vast network of life that depends on cells. By sensing, responding, and communicating, cells enable ecosystems to thrive. The living world is a microscopic symphony woven from their cooperation. The human cellular communication system. Our bodies consist of trillions of cells working together to sustain life. An astonishingly complex system. Its advanced technology we often overlook until we examine what it can do. With each heartbeat, your body generates signals, pressure waves in blood and electrical rhythms that ripple throughout you. The heart works in tandem with the brain, which tracks heartbeats, breathing cycles, and body sensations. The heart's pumping does more than move blood. It also conveys information about your body's state. Dennis Noble's Systems View. Dennis Noble, a founder of systems biology, argues that cells and their networks actively direct body functions. Genes aren't the sole controllers. Cellular communication goes beyond following genetic instructions. Cells exchange signals dynamically to maintain life-sustaining equilibrium. Noble's work on heart cells shows that the heart expresses rhythms that aren't simply commanded by the brain or reducible to genes. Heart cells have their own intrinsic timing and capabilities that influence other systems. This points to an interactive body, not a mechanical device following a fixed genetic blueprint. A note on relatable perspective. Dear reader, listener, or viewer, throughout Chapter 1, whenever you see relatable perspective in bold, it offers a quick, grounded angle on the preceding ideas. This chapter includes a mix of theory and evidence. Those sections are meant to connect the concepts to everyday experience. Relatable perspective. Think of the heart as the main control hub of a wide network, distributing data signals, and the brain as the central processing unit evaluating system performance. When your brain detects irregular heart rhythms, it can trigger anxiety and physical warning signs, alerts that something needs attention. The brain can signal the system, but the fix often emerges from broader body-wide adjustments rather than a single top-down command. Your cells act more like dialogue partners than order takers, in Noble's framing. Heart cells may speed up in response to brain signals, yet also send feedback about the rhythm that best meets local needs. The brain weighs that input, either accepting the current rhythm or proposing an alternative that fits the whole system. What looks like obedience is really ongoing negotiation aimed at meeting the body's needs in real time. Meanwhile, your body performs countless tasks at once: breathing, digestion, thinking, movement, without your conscious input. It's the most sophisticated coordination system we know, far surpassing any device we've built. The ongoing scientific debate. There's active debate around Noble's claims. Richard Dawkins's gene-centric view emphasizes genes as primary blueprints, while Noble highlights multi-level control by cells and networks in their environments. These discussions reflect the challenge of integrating fresh findings with established ideas. Noble's perspective is intentionally provocative, a reframing of how we study life and its control systems. While it doesn't discard Darwin or Dawkins, it shifts emphasis from a solely gene-first model to one where genes, cells, and environments co-regulate in networks. I don't dismiss Dawkins or Darwin. Their work remains foundational for evolution, genetics, and natural selection. Modern biology still relies on those insights. I see Noble's view as complementary, expanding how we think about causation and control in living systems. A YouTube conversation between Dennis Noble and Richard Dawkins includes a moment that struck me. Dawkins suggests we could, in principle, reconstruct a person from a complete genetic profile, even centuries later, DNA as a full blueprint. Noble counters that this is impossible because DNA alone isn't the whole story. Cells are in continuous dialogue with their environment, shaping development and identity through ongoing interaction. Relatable perspective. Identical twins raised in different countries share the same DNA, yet their diets, stress responses, and daily routines often diverge. Those environmental differences reshape cellular processes and can lead to health and personality differences. The example highlights how experience and context help determine who we become, beyond inherited genes. DNA alone doesn't capture the fullness of a life. That idea resonates with me because it suggests identity emerges from the continuous interplay between genes, cells, bodies, and environments, adding a deeper dimension to how we understand existence.